Hey, what's up, everybody? So we're going to be looking at 10.6 today, and the theme of this is solving quadratic equations using a new method called completing the square. All right. So real quick, get this title, and then I'll scroll down and show the 3 steps to completing the square, and then we'll try some of these out. Okay. So go ahead, take a second and get the 3 steps to completing the square. Okay, so first thing, we've learned a few different ways of solving quadratic equations. We've factored and solved, we've used square roots on both sides. So what completing the square is it's a different way, but the good thing about completing the square is it can be used on any type of quadratic equation. All right, it doesn't have to be factored. It doesn't have to, not have a leading coefficient or anything like that. So that's the good thing about this. So first thing, number one, we're going to find a new C value. All right, you guys remember, the typical form of a quadratic equation is this standard form. And what we're going to do first is figure out a new C value. Okay, we're going to get rid of that old C value and get a new one by using this formula, C equals B divided by 2 squared. All right, where, B is this number in front of X. Okay, from there, we're going to write what we have as the square of a binomial. All right, and basically all we have to do is divide our B value by 2 and write it in this form, and then it'll actually be in its factored form. This will make a lot more sense when you see it. Okay, and then the last thing is just starting to solve for X by first, taking the square root, undoing the squaring with square rooting, and, getting to the point where we solve for X. Okay, so yeah, it's a strange thing to think of. So let's actually look at an example. It'll make a lot more sense. Okay, so take a second, copy this example, and we'll do this one together. Okay, so first thing to know about this problem here, the C value for our quadratic equation has already been moved. Okay, the C value that would have been in this spot, which by the way, it probably would have been a -3, was moved to the right by adding 3 to both sides. Okay, so just so you know, that's why there's a spot here. All right. So the first thing we want to do is now figure out our new C value. Okay, and this is step number 1. Just a little reminder, we use this little formula, C equals B divided by 2 squared. So C equals, I guess for the sake of taking notes, let's show the formula and then let's plug in some numbers. Okay, our B value on this one, the number in front of X is a 2. So we got 2 divided by 2 squared. Okay, 2 divided by 2 is 1, 1 squared is 1. Okay, so there is our new C value. So I'm going to go ahead and rewrite this thing, x squared plus 2x, and I'm going to plug in that new C value we just figured out, which is a positive 1. Okay, here's the big thing. We just randomly added 1 to one side of our equation. Okay, what we have to do is also add 1 to the other side. So for now, actually, I'm going to make this green just to show we're adding 1, and we're also adding 1 to this side of the equation. Okay, whatever we do to one side, we have to do to the other. Okay, so from here, let's move on to the second step. Okay, step number 2 is writing our equation as the square of a binomial. Okay, and all I want you to just think when you do this step, all you need to do is write this out, take your B value and divide it by 2. All right, so I'm going to go ahead and write it out. X plus, we have B divided by 2 squared. Our B value again is a 2. Okay, so that's the left side of our equation. On the right side, we can add these together and get a 4. Okay, and you guys can see we're going to end up with a 1 inside of here. So let's go one more step and let's actually, divide those numbers. When you guys get good at this, you can probably just do the division on this step. If we're doing B divided by 2, 2 divided by 2, we could just put a 1 right here. All right, but I want you guys to have, good notes and be able to see it. By the way, listing off the steps, we don't need to do that. Like step number 1 is the only one that really requires doing something off to the side. Just okay. So anyway, let's go ahead and write this: x plus 1 squared equals 4. Okay. Here's what I want you to realize: x plus 1 squared is the factored form of this trinomial. If we were to factor this trinomial, okay, you don't need to write this, but we would get x plus 1 times x plus 1. all right, which we could turn into an x plus 1 squared. That's all we're doing right here. So the nice thing about this is we're factoring this thing automatically. Okay, and that is why we're figuring out and this initially this c value, because what it does is it turns this into a trinomial that can be factored very quickly. Okay, so that is the point of all of this. So anyway, let's keep moving. Okay, so that's the first two steps. The last step is basically solving for x. The first thing we got to do is get rid of this power of 2, undoing squaring by square rooting both sides. Big thing to remember, there's technically a plus and a minus in front of this square root. Okay, and there's also a plus and minus in front of this one, but you guys remember, I normally ignore that one because it just gets canceled out immediately. Okay, so what do we got? We have an x plus 1 on the left. On the right, we have plus or minus the square root of 4, which is 2. Okay, last thing is solving this thing. So here's what we got here. If I were to subtract 1 from both sides, okay, we would get x equals, and we need to do these individually. So we have a positive 2 minus 1, and then we also have a negative 2 minus 1. Okay, I'm going to write those as two separate things, and technically it would be an or between. Okay, so 2 minus 1 is 1, or negative 2 minus 1 is negative 3. And there are our two answers to our quadratic equation. Okay, so this is a really strange process. We're going to do one more before I have you guys try one. But just know, once you get used to this, it's really not that bad. I'm explaining a lot as we go through this, but when you do them on your own, once you get it, it'll be really quick. Okay, so let's try another one of these. Go ahead. The directions are going to be the same over and over, so go ahead and get this new one. We'll try it. Okay, so first thing to realize about this problem, I did not leave a spot for C. Okay, on this one I put plus C. Normally, that's not going to be written there. Normally, they just won't have the C value. Okay, so when we go to do our first step here, which off to the side, remember C equals, just a little reminder, B divided by 2 squared. Okay, so B divided by 2 squared. Our B value on this one is a 10. So we got 10 divided by 2 squared. Okay, 10 divided by 2 is 5. 5 squared, 5 times 5 is 25. Okay, so now we can write this equation out, putting in our new C value. So we got an x squared plus 10x, and then our new C value, which is a positive 25. Okay, and then over on the other side of the equal sign, we have a negative 8. And again, if we add 25 to one side randomly, we have to add 25 to the other side. Okay, so why did we do this? Because we just created a perfect square trinomial, okay? And that can be written as a square of a binomial. All we have to do is take x plus, plug in our b value, divide it by 2, and we're going to have the factored form of this trinomial. Okay, we'll do that. We'll plug in that on our next step. Okay, over here, 25 minus 8. What does that give me? Why don't I want to do that in my head? 17. There we go. I didn't want to mess up. Okay, so now let's plug in our b value. Really, we could have done that on this step. Actually, let's do it on this step. Let's erase b. Okay, sorry. And let's just put 10 in there. Okay, so next step, dividing those numbers, we got x plus 5 squared equals 17. Okay, and then from here, now we can start solving for x. Again, we're going to undo the squaring with square rooting, both sides. I'm going to put the plus or minus next to this one. I'm going to ignore it on the other one because it's canceled. Okay, so I have an x plus 5 equals plus or minus the square root of 17. All right. From here, solving for x, I'm going to subtract 5. All right. And put it under here. Here's the thing. It depends. If we're on like Delta Math and they asked for it to be rounded to a certain decimal place, we would, type in the square root of 17. We'd take the positive, the negative, we'd write the two things. On this one, I'm trying to think of what I want to do. Because here's what I'm running into. We can write it like this. Plus or minus the square root of 17 minus 5. All right, and that kind of incorporates our both of our answers. But I think I want to actually do the decimal. So let's actually get the square root of 17. Okay, so if you grab a calculator, the square root of 17 is 4.12. So we're just going to round that to 4.1. So I'm going to say a positive 4.1 minus 5, or x equals a negative 4.1 minus 5. Okay, so this will actually give us answers that, look, halfway decent. So let's see, 4.1 minus 5 gives me a negative 0.9, or over here, negative 4.1 minus 5 is going to give me a negative 9.1. Okay, and there are my two possible answers. Okay, so I guess when you guys get radicals that are not perfect squares, I still want you to type that into a calculator and get a decimal on these. I think that's what we'll do on any of these problems, unless they ask otherwise. Okay, cool. So I want you guys to try one of these. So go ahead and copy this one here. First, find that new C value. Make sure you add it to both sides. And then, step number 2, step number 3. Go ahead and give it a try. Okay, so our C value, again, b divided by 2 squared. Our b value on this is a 10. So again, we're getting 10 divided by 2 squared. This is, the same thing that happened on the last one. 5 squared gives me a 25. All right, so when I go to rewrite this, I got an x squared plus 10x, and my new C value is a positive 25. Over on the right, I got 24, and I have to also add that 25 over there. Okay, and I just want to point out again, this is what's called a perfect square trinomial, and that means it can be factored by writing it as a square of a binomial. All right, just so we're all on the same page, remember, that means just taking x plus b divided by 2 and then squared, just writing it in this form. All we need to do is do that math. Okay, so we got x plus our b value is a 10 divided by 2 squared. Okay, and this will give us the factored form of this trinomial. We don't even have to use the x method or anything like that. Over on the right, looks like we have 49. Okay, so just going one more step, let's divide those numbers. X plus 10 divided by 2 gives me 5 squared. All right, and now finally we can start solving here, getting rid of the squaring by square rooting both sides. Don't forget the plus or minus. Okay, so over on the right, those cancel, and I have an x plus 5 on the left. Over on the other side here, the square root of 49 is a perfect square, so we're getting plus or minus 7. Okay, if you don't know that's a perfect square, again, just type it into a calculator. Okay, so we have two things. When we go to subtract 5 from both sides to solve, okay, we're getting x equals a positive 7 minus 5, or we're getting x equals a negative 7 minus 5. Sorry, let me write that a little better. Okay, so either x is going to equal 2, or x equals a negative 12. All right, so kind of went quick on that, but I just want to show you, once you get used to these, really, they're not too shabby. There's just a really strange kind of process here. Okay, so I just have a couple more slides to go at. So let's try one more of these problems. You'll see why this differs a little bit. Go ahead and copy this, same directions, and then we'll try it. Okay, so here's the first thing to notice on this problem. There is a C value in this spot. Here's the thing. We don't like this C value. The reason why is because this thing cannot be factored easily. It is not considered a perfect square trinomial. Okay, so to get a perfect square trinomial, we need to find that new C value. Okay, before we can plug in that new C value, though, we need to get rid of this old one. So I'm going to subtract this 15 over to the right-hand side. Okay, so those are gone. I got x squared minus 8x. I'm going to leave a spot for my new C value right there, and then I have a negative 15 over here. Okay, so this required an additional first step. Okay, but all it was is just getting that C value to the other side so we can plug in our new one. Okay, so let's get our new one. C equals b divided by 2 squared. All right, our b value on this one is a negative 8. So negative 8 divided by 2 squared. Negative 8 divided by 2 is a negative 4. Negative 4 squared, negative 4 times negative 4, positive 16. Okay, so there is my new C value, positive 16. But if I add 16 to the left side, I have to also add 16 to the right side. Okay, now this is considered a perfect square trinomial. Step number 2, now we can write this in its factored form. Okay, x plus b divided by 2 squared. Our b value is an 8, so plus negative 8 divided by 2 squared. Over on the right, just doing this, 16 minus 15 gives us a 1. Okay, so real quick, let's do this division here. So x, negative 8 divided by 2 gives me a negative 4. I don't want to write plus negative 4. It's just going to be minus 4 in here. Okay, over on the right, we have that 1. Okay, that was step number 2. Step number 3, finally just solving this thing. First, taking the square root of both sides. Don't forget the plus or minus. Okay, so those are gone. I got x minus 4 on the left. On the right, the square root of 1. The square root of 1 is actually a perfect square. 1 times 1 gives me 1. So square root of 1 is 1. Okay, so last thing, or almost last thing, getting rid of this 4 by adding it to both sides. Okay, now we can write this as our two different equations. We have x equals a positive 1 plus 4. Okay, or we have x equals a negative 1 plus 4. All right, and last thing here, x equals 5 or x equals 3. Okay, so yeah, completing this square. I have one for you guys to do, but I just want to point out this is kind of a nice foolproof way of solving really any quadratic. That's what's nice about it. Okay, so I'm gonna have you guys go ahead and try out one last problem on your own here. Go ahead and copy this. The first thing we want to do is get rid of this old C value, and then you can find that new C value, just like we've done before by plugging your B value into this. Okay, so get rid of that old C value and then find that new one. Okay, so getting rid of this minus 21 by adding it over to the right. I have an x squared plus 4x. This goes away, but I'm going to leave a spot for my new C value. Over on the right, we have positive 21. Okay, getting my new C value, I'm going to plug in my the B into this. So B is 4, so 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. Okay, so there is our new C value. So I'm going to add 4 to the left, and that means I have to also add 4 to the right. This adding 4 to the right, this is a really easy step to forget. And if you do, kind of messes up the whole thing. Okay, step number 2 is writing this thing in its factored form, which is x plus b divided by 2. Our b value is a 4, and then squared. Over on the right, looks like we have 25. Okay, so real quick, x plus 4 divided by 2 is 2 squared. Over on the right, we've got that 25. Now we can go ahead and take the square root of both sides. Start solving this thing. Plus or minus. All right, so these are gone. We have x plus 2 on the left. On the right, the square root of 25, again, is a nice perfect square. We had a lot of perfect squares on this. Remember, you won't always, but if you don't get a perfect square, do it as a decimal unless told otherwise. Okay, so square root of 25 is 5. All right, so from here, getting rid of that 2 by subtracting, now we can write our two equations. X is going to equal a positive 5 divided by 2, or not divided, minus 2. Or x is going to equal a negative 5 minus 2. All right, and let's see, that means x equals 3, or x equals negative 7. Okay, so yeah, that is using the method called completing the square. One thing I want to point out, if we were ever to do this math and end up with a negative number underneath our radical, say we did our math and this turned into a negative 25, we wouldn't be able to do anything. Because remember, you can't take the square root of a negative number, or at least not in normal algebra. This gets into imaginary numbers, which we don't deal with in this class. Okay, but if this were to ever happen, first of all, you'd want to double check your work and make sure that you do actually get a negative. But if you did, you'd be done here and you'd have a no solution problem, just so you guys know. Okay, but all of these problems that you're going to run into, or at least almost all of them, will have a positive number underneath that radical. Okay, cool guys. So that's that. I'll see you in class. Bye.